Hi, welcome to class. My name is Don LaFon, Professor Don, and this week in our A+ software class, we are finishing Chapter 13, Networking. Bunch of topics we're going to cover over, again, at a pretty high level, but this material should help you finish off the concepts for learning about networking. Now, I want to encourage you all, even those of you out on the internet, on YouTube, to watch my Cisco, the 3 subnetting videos that I showed that I created for my Cisco network. I'm going to incorporate those into the playlist for A+ software. Now, the reason I'm going to do that is because there's very little material in our textbook on subnetting and a couple pages in the appendix. It is important for you to understand the concepts of subnetting because it could be testable in A+. And then later, when you move into a networking class, if you are earning additional certifications, these 3 videos will help you. Is it required for your A+ certification? No. Subnetting and BLSM is on a really high level that will, they're not going to give you a Class B network and ask you to break it into multiple networks and tell you host names and whatnot. But this knowledge, if gained at this level, will help you to be prepared for networking concepts in the future, perhaps when you move on to your networking class. All right. If you are here with me now and you have any questions, please hold your questions until I'm done with the presentation. Then you can ask your questions. If you are in our classroom, our Canvas classroom, and you have any questions, please ask your questions in the help discussion forums. And if you are in our, if you are watching this on YouTube, please ask questions in the comments down below. I also welcome your comments just to say hi, the information is helping you, etc. I do love to hear from the people watching my videos, especially if you're finding that they're helpful for you. Okay, 1 second. Okay, we are set up for the beginning of Chapter 3, pages 650 through the end of the chapter. Now, it's actually a bigger chunk of pages than Part 2, which was only, I don't know, 8 pages or something. But there's a lot of concepts here that we just touch base on. And make sure you're reviewing the actual textbook. If you have this textbook, you can find it online as well. This is the Complete A+ Guide to Hardware and Software by Cheryl A. Smith. And it's for the A+ Core 220, 1001, and 1002 exams. Great book that will definitely help you get ready for that A+ certification. All right, here we go. So the first thing they talk about is VLANs. Now, VLANs allow you to segment a network without having a router in between. Routers exist to divide networks. So you can have the instructor network, you can have the student network, administration network. They can all be a different network. Now, VLANs, what that allows you to do is to take one switch that's connected to a router, and you can control or segment, I should say, the hosts that are on that network, so that you can like having separate networks themselves. You will be able to have actually, in this case, they're showing you they're assigning 17, 18, and 19 for the VLAN in different networks, but you can do it with using a switch instead of using a router. The switch is what's controlling the VLANs, and you can, going a little deeper than that, is it's controlled by tags. The device itself, these devices don't know that they're in VLAN 17, 18, and 19. That's controlled by the port. The switch puts up, you configure the switch to put a VLAN into a host into a specific VLAN. Then when the host sends a packet of information, it's tagged with that VLAN, and it stays that, and then it remains on that on that network until it gets to the destination. When it gets to the destination, the tag is removed and it arrives at its destination. Wireless networks. Wireless networks obviously they're wireless. They transmit data over the air using either infrared, 1 to 400 terahertz range, or radio frequencies, 2.4 gigahertz or 5 gigahertz. You're familiar with the radio frequency RF range for all of your Wi-Fi um, IoT devices. Anything that's dealing with connecting to, say, your router is going to be in this range, 2.4 or 5 gigahertz. They operate at layers 1 and 2 of the OSI model. Remember, we talked about the OSI model. Layer 1 is physical, and I know it says physical. You would think copper or fiber, but in reality, wireless is a physical layer protocol so that you can send information wirelessly at the physical layer. Just go with me on this, all right? Layer 2, remember, hop to hop. We're going from we are going from NIC to NIC. Layer 2 is usually switches. That's what we were just looking at a moment ago. That is where wireless operates. When we get to layer 3, we're talking about IP address, and IP doesn't care. IPv4, IPv6, it doesn't care whether it's on wireless or fiber or cable or copper cable. Bluetooth is one of the wireless technologies. It's used for personal area networks. Devices include audio-visual products, automotive accessories, keyboards, mice, mics, phones, printer adapters, lots of small wireless devices. You probably have wireless ear headphones, earphones, and you probably have a portable speaker. That also would be an example of Bluetooth. It connects via Bluetooth. Wireless works in the 2.4 gigahertz range, similar to business wireless networks. It has 3 classes of devices, class 1, 2, and 3, that have a range of less than 30 feet. That's 1. 2 is 33 feet, and 3 is 328 feet. You probably have your speakers, your earbuds. They probably are class 1, although you might be able to find them in class 2. 30 feet is becoming more popular. I can get about 30 feet away from my Bluetooth speaker with my phone, and then it starts breaking up. Breaking up is in losing the signal. It's digital, so you either have it or you don't have it. The newest version, 5, supports longer distance, but they're not defined as to the max yet. 802. Now, the standards you need to know: 802.11a, 802.11b. Believe it or not, A came after B. They were both racing to be the first, and B beat A. So B came out shortly beforehand. It has a speed up to 54 megabits, but is incompatible with 802B, and it operates in the 5 gigahertz range. 802.11b operates in the 2.4 gigahertz frequency range with the maximum speed of 11 megabytes. So A is faster than B, but a shorter range. 802.11e provides standard related to quality of service. G kind of combined one and A and B. It's 2.4 gigahertz with speeds up to 54 megabytes, and it is backwards compatible to B. And of course, we have more that have come out since then. Those standards are hectic. They've got to be 30 years old. Today, we're dealing with N, AC, AD, and AX, which isn't even listed here. But 802.11i relates to wireless network security and includes AES, Advanced Encryption Standard. We'll talk more about security a little later for protecting data. 802.11n operates in the 2.4 and 5 gigahertz range. It's backwards compatible to 802.11a, b, and g. It has speeds up to 600 megabits per second using MIMO, meaning multiple antennas, and has a maximum of 4 simultaneous data streams at the same time. 802.11ac operates only in the 5 gigahertz range, which makes it backwards compatible with 802.11n and 802.11a. Speeds up to 6.9 gigabits, almost 7 gigabits per speed, with 8 simultaneous data streams. And then 802.11ad, known as Y-Gig, works in the 60 gigahertz range, speeds up to 6.7 gigabits. AD didn't really latch on with the consumer because the range, yes, it had a faster connection speed, but I watched a couple of videos on it. I never had any equipment in AD, but I watched multiple videos that all talked about you could almost be back-to-back laptops back-to-back with a person standing in between the two, and they wouldn't reach each other. Yes, the speed was fast, but because it's in the 60 gigahertz range, it didn't have much ability to penetrate walls or even a person. So that didn't really latch on. Today's standard is AX. I've even seen other standards that are in the tentative stage, but AX is what all of my equipment is in my home. And AX is basically high speed with dedicated streams of data. You can look more up about AX. What the important thing about all of these standards is you don't want to go to your local store and hey, they have an 802.11b a router for just $10. We should buy that. No, don't do that. Always buy a cutting edge technology because you're going to get longer range, faster speed. Of course, that's with the exception of AD. AD didn't quite work out. But AC and those are acceptable, but don't buy anything older than that because it's you're not going to be happy with it, and you'll be wondering why your speed isn't fast or your range isn't far. Now, wireless devices, you have obviously routers. They connect. You're in your home, you have a wireless router most likely. It looks like what you see at the top of the page. That's a wireless router that actually probably have ports in the back like this. Those are switch ports to be able to connect wired devices. And then the wireless access with up to 8 antennas, today's standards, and those antennas broadcast the signal throughout your home. So it's wireless, and wired. Now, an access point, you may have access points in your home, but you more likely most often see access points in a corporate environment. For example, our college has access points in each one of the classrooms and in some hallways, and the student center and all of the offices, not individual offices, but like in a group of offices. We call them a suite of offices, and they'll have a wireless access point. And the purpose for the wireless access point is to propagate or rebroadcast the signal from the router. The router sends the signal to the access point, which then rebroadcasts it, refreshes the signal, and then rebroadcasts the signal. There's a bridge, connects 2 or more networks. We really don't use bridges anymore in today's networking, although you may hear the term. You can convert a router into a bridge where the router actually doesn't do anything more than to transfer the signal. but even that is becoming less and less popular. NICs, remember we talked about NICs earlier. Every single device that connects to the internet has to have a unique NIC, the network interface card. It has a burnt-in MAC address. We talked about MAC addresses already, previous video. The MAC address is the device's unique address, just like your home address is unique in the world. The MAC address is unique regionally. So those NICs have burnt-in MAC addresses, and the MAC addresses help to allow for layer 2 communication. Power over Ethernet. Power over Ethernet is important for those APs. You find these APs in the ceiling, and you don't usually have plugs in the ceiling. So you need to have a network. You have to have a switch that has the capability of injecting power directly into the switch, which then passes it along to the access point. Or you can use an injector. The switch doesn't have power, but then you add an injector that then your signal leaves the switch, goes into the injector, which adds power, which then is forwarded to the access point. So this would be for current equipment when you're buying new equipment and you know that you're going to have access points and you need to pass along power to those access. And this would be stepping backwards. You already have your access points, you already have your switches, but now you're realizing that, hey, I need to power those access points. So, and my switch doesn't have that capability. Instead of buying new switches, you can use a PoE injector. Now, wireless channels. The wireless channel in a network, there are several in each networks, whether we're talking about in IP, what they're showing you here, they're talking about how your yeah, sorry, your 2.4 gigahertz spectrum. That's what I'm looking for. Your 2.4 gigahertz spectrum is going to have a number of channels. In this case, they're showing you 11 channels, and they're showing you that the signals overlap. So ultimately, if you want a clean signal from each network, you would devise a layout of your APs so that the signal does not overlap, and that gives you a clean signal. Your wireless devices at home operating on the 2.4 gigahertz, that wireless device automatically switches between channel 1, 2, 3, 4, 5, 6, whichever is less noisy, there's less traffic on it. But when you're in a corporate environment, you really should set your channels manually inside of the equipment so that there is no overlap and you'll have a much stronger signal in your network. Now, what you see on the right-hand side is you see the distribution of, let's see here, hang on a second. Okay, so I went ahead and made a little change to this PowerPoint. I apologize for, well, you guys don't know there's a delay. But anyways, it's a lot better presentation. I got a couple more slides that will help. So this was the 5 gigahertz channel IDs, but really hard to understand this. So what I did was all they're trying to say there is we operate in this range of the network, whether we're dealing with 2.4 at the lower end, including your microwave, and then the infrared, that the higher 5 gigabits. And then obviously we're not in x-rays when we're talking about communications, okay? So that's what they're talking about with this picture here, talking about different antennas that operate at different ranges. And what they were talking about earlier with the 2.4 spectrum and how they overlap Well, the same thing happens with the 5 gigahertz standards. It's divided up into different networks with each network with 20 megahertz in between each network. And the clean ones you can follow. The clean ones you can follow. So it would be 36, 48, 60, and that's what it says there. Those would be the clean ones. Now, what am I talking about, the clean ones? Well, you don't want overlap. You don't want it when you're just when you are deploying your access points. You want those access points to have a clean signal. It's not like they can't overlap other ranges, but you don't want, for example, 36. You wouldn't want the first one to be on the range 36 here and then 36 here again. You would want to separate them. So you can see here that let's say you start with the first range, second, third, the first range, the first group, 36, you could deploy here. The same thing's true with the 2.4 gigahertz spectrum. You're trying to uh, take the geographical layout of your workspace because you're not putting a bunch of APs in your home most likely, and you are trying to lay out those APs so that they're not overlapping, and then you run power to them using the power over Ethernet, and that's how you lay out a proper wireless LAN deployment. Just that simple. When we're talking about the actual transmission of data, today's access point use multiple 2.4 gigahertz or 5 gigahertz MIMO antennas, and the further away you are from the PA, the slower your device transmits. So what we're talking about here, the access point, they have a typo. Yeah, let me fix that. 1 second. If I don't fix it now, I'll say the same thing next time. Hold on. Okay. Just proof that the people that create these slides are not always paying attention to the details. So anyways, the further away you are from the access point, the slower your device transmit. And you've seen this with your devices, even in your home. The further away you are from your router, your wireless router, or whatever repeater you might have, the slower your connection is. And that's just because it literally has to transfer further, and you're competing with other devices as well. You may be competing with other devices. So it is something to be aware of. So we adding another, in my home, I have something called a mesh network. Mine is an ASUS mesh network, which is somewhat like what we were just looking for. And I could probably go in and configure it manually, but the mesh network, it controls itself. It assigns its own, everything's automatic, and they're laid out. I have 4 of them in my home, and I have a strong signal no matter where I am. Now, wireless security. You can take an entire course at our college on wireless security, and they talk about that every single one of these, no security at all, WEP, TKIP, TKIP, WPA, WPA2, WPA2 with AES, and there's even a WPA3 that is starting to be incorporated in companies, just that much better security. But I want you to read the textbook and watch another video on security that goes in depth on each of these, because you're not going to get it in a quick overview. Matter of fact, I may put a security video up to cover these concepts, but not just yet, okay? So you're going to have to find somebody else's video for these concepts. It's important because you may get a question on the A+ certification asking which of the following is today's standard. And if you are in the 220, 1001, 1002 Series A certification, which is the summer of 2022, you would say WPA2 is with /AES is the most secure. But the next standard, I suspect the most secure would be WPA3. So watch for that. And it also helps you to learn. But again, I took this class and we spent I won't say a week on each one, but we definitely did not cover it in the 5 minutes that I have to cover it. Just take a few notes, put it on your index cards, your test prep index cards, and you'll be ready to go. End use device configuration. Well, how do you go about configuring all of your devices? Well, the first thing you need to do is give each device a name and optionally join a workgroup or domain. Now, I've already mentioned in this course that that they took away the capability of workgroups in Windows 10, and they don't even exist in Windows 11. So that has gone away, but they do exist in Windows 7 and Windows 8. And if you haven't upgraded to the newest version of Windows 10, you will have workgroups in Windows 10. You configure the IP addressing. You can allow DHCP automatically to assign addresses, or you can statically configure them. I'll show you on the next slide how to go about configuring either DHCP or static configuration. You can optionally enable file and print sharing, where one device is perhaps you have a printer. I don't see a picture here with a printer, but if you had a printer connected to this device here, you would configure it as a print server, and you would have set an IP address, and this would become the print share. Although you could set the printer as its own device connecting to the server, and then the server handles the print spooling and print sharing too. So there's a couple ways to set up a file or print sharing. If a wireless device is being configured, you have to select the wireless network or configure the SSID and possibly enter security parameters like we just talked about, the different options. And SSID is just the name of the device. So I think my wireless devices in my home are called LaFawn's Internet. My name's Don LaFawn, and I just made it LaFawn's Internet to be obviously my network. I don't know if that's a great idea, but somebody would still have to know the passwords to be able to break in. So I didn't see that as a danger. But you may not want it to be so obvious, and you can set your SSID to any name you want, like home internet, instead of leaving it with the name that came from the ISP when they installed your router in your home. Now, this is setting an IP address configuration. Open up your network, Internet Protocol version 4 properties. Open up your network, go to the properties for IPv4, and you either set a DHCP by obtaining an IP address automatically, put a check in this box. Any router can be configured to hand out DHCP addresses. Your home router usually does this for any private addressing in your home. In a company, you may have a DHCP server that hands out addresses, and that DHCP server will hand out addresses from perhaps more than one pool. So there could be pools for your student network, for your teacher network, for your admin network, and addresses have to be handed out automatically. Now, of course, you can also set your addresses manually by going into the configuration here and actually putting an IP address in the correct network that you have determined, your subnet. Talk about that at the end of this presentation. It include the right subnet mask for the IP address. It usually fills this in for you automatically, but verify it did it correctly. And then set the default gateway. The default gateway is the IP address of the router that is dividing your network from other networks. So you have to have an IP address. If you're setting up a VLAN, you have to use a router on a stick beyond the scope of this class, but it's where one interface can be divided into multiple networks using the same interface, and you do that using sub interfaces. Again, beyond the scope of this class, you'll get that when you get to your networking class. But don't be afraid. You can have multiple VLANs on the same cable that's going to your router with different networks. You can absolutely do that. You just have sub interfaces, and it's called router on a stick. And setting DNS server is optional down at the bottom, but this is manually. Now, the reason why we use a DHCP server is because the last thing you want to do is, say, go into a classroom like my physical classroom where there's 24 computers for the students and have to go through each computer manually at the device setting IP addresses. Not only is it time consuming, but there's a high chance you're going to make errors, which are then extremely difficult to troubleshoot later. You pretty much always want to use DHCP unless you're setting up a reserved IP address, and that IP address could go to a printer, for example. And that printer, you wouldn't want this printer's IP address to change because you want it to be always the same. And you don't want the pool of addresses handing out the address to another device. So then later, when somebody tries printing, it goes to a PC. Remember, your printer will be turned off and turned back on again. When your computer gets turned off and turned back on again, and it gets a new IP address, not a big deal. You're at the computer. But if you set an IP address on a printer, you want to do that statically so that when you turn off the equipment and turn it back on again, it doesn't lose the IP address, and then you have to remap that IP address. I think that's probably enough there. APIPA. So when a Windows computer is set up for DHCP, but it does not receive an IP address from a DHCP server, an automatic private IP address, APIPA, is applied. Now, PIPAs, you'll recognize them because they start with 169.254. Now, if you see an address that has a 169 anything after it, but let's go with 169.254. If you see that an IP address in the APIPA range, that computer will not be able to talk to the internet. It will only be able to talk to other addresses on that network that are also in that status. So you might be able to talk to another computer on, say, in the classroom, but you can ping the computer next to you, but you on the APIPA address of that computer because you're on the same network. But you would not be able to reach out to the internet and, say, hit the router and go off to some distant IP address. Not happening, because APIPA is only when you're having a problem with DHCP. Check the computer has connectivity, the cable is actually plugged in, and try using ipconfig/release and ipconfig/renew to reach the DHCP server again. It'll actually release the APIPA address and then try to reach out for a DHCP address. Now, the default gateway I mentioned briefly once before. This address right here, usually either the first address in a network range or the last address. In this case, they're setting it to 193.150.1 for this address. Notice this is 151. This is the 151 network. That's the 150 network, and they both use the first address as the the default gateway. Now, when a device sends a packet to an IP address that is not on the local network, it has to go through a router, and then that router will will know where to send it. So if somebody, let's say 193.1.152 is sending to 193.1.151.4, it needs to go to the router. The router knows where this address is. It sends it on its way. But if it doesn't know, then this router would have to have its own default gateway going up to the ISP or some maybe edge router on your network in a big corporation. So that's what default gateway stands. Now, these devices can all communicate with each other without a problem. Usually there would be a switch. These things don't just end in a line. Usually there's a switch right here. So these devices would all talk to each other. So 150.2 can print and 154.4 can print, but they can't print over here. They can't talk to these computers. Same thing over here. 151.2 can print, 151.4 can print, but they can't reach over here. That's what the default gateway is for. Routers separate network. They divide broadcast domains, really an important concept to understand. If there's a problem with this network, it will not affect this network because there's a router dividing the networks. Oh, let's see. Let's see. The default gateway address is always a different IP address, but it's always in the same network. Thin client installation. Now, all they're talking about here is that some computers have all of the software loaded on the computer. That is a thick client. A thick client has applications installed locally, like Microsoft Office, for example. Image management software is used to install an OS and drivers. We call that a ghost image. We create a ghost image, say, for an entire classroom. And you set up that ghost image to include all of the software that is going to go onto each individual computer. And then you go from computer to computer, and you can do it remotely, but often it's done in person. You can do it from computer to computer, and you put that CD-ROM, or today's we use a USB drive, and you install the software manually from computer to computer to computer. Some unique apps must then have to be installed manually. So the ghost image will have all of the standard software, and then it's frozen. But that way it doesn't change. Computer can turn off, turn back on. It has all the same software. Students can install a virus on the computer. It doesn't matter. You just reboot the computer and you go back to the boot clean installation automatically. Now, if there's unique software, like I have one lab in in our technology department, one lab has Photoshop installed on each one of the computers, and that one lab, the technicians had to go manually, either doing it remotely or in person, and unfreeze the hard drive, install Photoshop, and then freeze it again. That way, when that computer rebooted, it would have Photoshop on it. Configuring options include network printer, local printers, application account settings, computer settings, including desktop icons, wireless options, and even things like freezing the desktop so you can't put your own picture in the background, just to keep your network a little bit more secure and appropriate for all audiences. We never had an incident at our college where a professor put something inappropriate as a background, but I have heard that that's happened at other schools. So at our school, it's the college's logo, the college's name, some pretty blue background, and that's it. Everybody's got the same background, and that's an example of a setting that can be set and frozen, so then you can't go back in and change it later. There's other wireless device configuration, and again, there's one line of text for each one of these in our classroom. Basic QoS, that's quality of standard. So we're talking about wireless, what has priority. Voice, for example, and video has priority over a FTP transfer of a file, which has priority over somebody surfing the web. A blacklist is a bunch of websites that you can't get to because they've been locked for anything inappropriate for a college environment is locked. Channel IDs we talked about before. DMZ, that's a demilitarized zone. That is an area that can be accessed directly from an outside network. Usually it's defined with, or it has a public IP address assigned to it. A good example for that would be a server that maybe is the web server for your company. It's given its own IP address that is directly accessible from the outside world. DHCP, I've already talked about sharing or distributing IPv4 addressing. Could be IPv6, but we're not going to get into that. Firmware, just the software that's loaded. Make sure you have the most up-to-date firmware on your routers, which reminds me, I don't have the most up-to-date firmware on my router, but I got an error message when I tried to update it last time. Should try that again. NAT, you set up NAT. It's configured automatically when you are dealing with IPv4 addressing. Basically, it's what allows you to have private addressing behind the router and then public addressing in front of the router. It's actually not set up automatically. You have to configure that setting up your when you're setting up your network to allow for inside and outside addressing. Again, way beyond the scope of this class. You get to Cisco 2 before we learn about how to configuring NAT to give you an idea how far down the road that is. Port forwarding, some of you gamers out there might understand if you get a game that goes to a specific port, instead of having the router NAT the address or a private address, you just forward any traffic going to that port and that's true at UPnP as well. It's another way of port forwarding or current. SSID, I already explained, that's the name address of your network. You configure it or you can leave the default. And then security options. We spent an entire chapter on that in chapter 18. So that's good that they pointed it out there. I don't feel so guilty about skipping that earlier, because we'll spend a whole chapter. That reminds me, we'll spend a whole chapter on it in this class. So hang on for chapter 18. We cover it next week. Now they talk a little bit about IoT, Internet of Things, and smart devices. They can be on a wired Ethernet, 802.11 wireless, Zigbee, and Z-Wave wireless, or proprietary wired or wireless network. Although I'd like to recommend that you do not use a proprietary wired or wireless network because it just makes it that much harder for the interaction of devices. You want devices to be either 802.11. They can be Bluetooth. They can be Zigbee, Z-Wave. My front door lock and half my lights is Zigbee. I'm not sure what the AI communicates on. You can put that down below. I hate to say her name, but Alexa communicates on one. I'm pretty sure that's a wireless connection because I have to set that up individually. But I know that Zigbee is pretty cool. The more devices you have, the stronger your network. But we'll get into that a little bit more on the upcoming slides. Zigbee is frequency 915 megahertz to 2.4 gigahertz. Range speed up to 250 kilobytes, up to 328 feet, 100 meters. And security, it uses 128-bit AES, which is the best encryption that's currently available. Z-Wave has some 908.4, 908.42, and 916 megahertz. United States is the first number, Canada is the second, and Mexico is the third. Up to 250 kilobits per second, up to 328 feet, and it's proprietary and improved with security too when we talk about its security. Now, Zigbee is pretty neat. Zigbee, each device is not only a receiver, but it's also a transmitter. So each device communicates with a hub, and then it can send devices from device to device to device. Now, everything looks like it's going to the hub here, but I actually shared with you earlier that here we go. We've got it here. We're talking about devices that talk to other devices that ultimately get to the center coordinator. Now, in my home, I had a problem with my lock, my front door lock, actually, that was a Z-Wave. Let's go to the Z-Wave. I'm sorry, Z-Wave is what I'm talking about, not Zigbee. Zigbee everything has to talk to the center hub. Z-Wave is the one that every device is a transmitter and a receiver. And there is a maximum of 4 hops between one device and a controller. Like this light here can talk to the thermostat, which talks to the outside light, that talks to the inside light, and then ultimately to controller. So we got 1, 2, 3, we're good. It's a when I had a problem with my front door lock not working, and I called the manufacturer of that front door lock. They actually told me, "Well, where's the closest device between you and the lock, the lock and the closest device?" And I said, "Oh, one's in the bedroom and one's in the living room." And he goes, "Well, you need to put something in between because it's not making the signal." So sure, I didn't believe him. I had no confidence at all. But I put in a lamp right where they told me, and sure enough, my lock, smart lock on my front door started working. I was a disbeliever, and then I was a believer. So, Z-Wave, the more devices you have, the stronger your mesh network. That is not true with Zigbee. So I apologize for mixing those two up, but you can see the difference. Everything goes to a center hub. If it doesn't have a center hub, then you have to have a router that will transmit the data like a repeater in wireless. But Z-Wave is the one that has hops. Now, the neat thing is you can actually remember that, and I should have remembered that. I'm going to move this slide Z-Wave first because Z-Wave actually makes it look like it's going from one location to um, another location to be able to work. IoT devices. I have a ton of them in my house. I just bought another smart device. I bought, believe it or not, a smart scale. And I am so impressed by my smart scale. It, first of all, it's smart. It does a whole lot more than weigh me, but then it automatically updates all the information to my phone using a free app, using Google Fit, and everything all connected correctly. And now I can monitor not just my weight up and down, but I can monitor my bone mass, my water intake, my fat mass, my body, what is it, body weight, BMI, whatever that stands for. But anyways, I was pretty impressed by it. And so one more device to include when I talk about this, and when I say I have a coffee pot and a dryer and a range and someday a refrigerator, they're all smart. Oh, and I have a smart thermostat. Remotely control, I can turn on my temperature, turn it off anywhere in the house. I can, just by saying, Alexa, set the temperature to 75 degrees.
AC is set to 75.
And she does what I ask her to do. She's pretty impressive. I apologize to all of you out there that just had your AC changed. Light switches, turn it on. I have like 30 light bulbs, all multicolor, so I can make different rooms different colors. Security cameras, I access them all remotely when I'm not even at the home. My door lock I already told you about. It's play music in any room in my house based on my AI. I love IoT devices. I really do. And you are going to be, you might be someday in the business of repairing, replacing, installing smart home devices because I'm on the cutting edge. I have all of the cool devices because I'm a tech guy. But someday grandma is going to want all these things and she's not going to know how to install them all. And you as a technician are going to perhaps a business of installing them for grandma, or you will have a business of repairing them when they're not quite working, and they don't always work. My dryer right now is not talking to my network, and I should go fix that. But don't be surprised if IoT ends up being part of your future. Network troubleshooting, use the ping command to see if you can reach other devices. You just type ping and then the IP address. It's that easy, ping and then the IP address, or you can actually ping a an actual URL address as well, comptia.org in this case. Use the ping command followed by a specific URL works. You can use ipconfig or ipconfig or IP or ifconfig if you're on a Mac computer, or a ifconfig is also for Linux, but IP is for Windows, to see if the device has an IP address and a default gateway. Just do ipconfig/all to see all of the information. Use tracert on a PC to see how far the device can reach. It's tracert and then a space and then an IP address or a domain. And then it will give you each hop along the way. It'll tell you how long it took to get to each hop until it gets to the ultimate destination, and then it says trace complete. Or if it fails, you can see how far along you get. If you ultimately seeing how far you can get will determine your how far you can get will determine where the problem starts. So if, let's say, it stops here, then well, actually, it would ultimately be up here inside of your network. If you could get, if you're in 192.134.5.6 and you can get to 192.168.1.1, that's your gateway. But you can't get past it. This one here, 10.123, this is also a private address, so that's probably your edge router. If you can get here but you can't get any further, then there's a problem with either the outgoing interface of your router or your default gateway's outgoing interface, the cable in between, or the incoming interface of this router, or this router is just not working, or that router is not working, but you can't get past it, so you can't get out to the internet. If the problem's out here someplace, if it's on the other end, like you can get to 216.55, but you can't, and 198, but you can't get any further. It doesn't complete. Well, then maybe there's a problem with the other side's default gateway or edge router or the device itself. So if you know an IP address of a device on the other end, ping it, and that'll help you narrow down what the problem is. Tracert is for PCs. Traceroute is for routers. I'll give you a hint now, help you out later. You can remember between the two, they do the exact same thing, except Tracert does it on a PC. Traceroute does it on a router. Traceroute has the word or part of the word router in it. That reminds you that it's for a router. You'll never make the mistake of trying to run tracert on a router or traceroute on a PC, because traceroute has router in it. It's for routers, and tracert doesn't, so it's not for routers. It's for PCs. Hopefully that helps you no matter who you take for networking down the road. Use the NSLOOKUP command when troubleshooting DNS issues to see if the problems with your company's DNS server, or if you're having a problem maybe with the wrong DNS, or if maybe the place you're going to is having a problem, or maybe it's not even online anymore. I own donlafon.com, and at least twice since I bought it in the late 80s, early 90s, probably in the 90s, I bought my name. It's a safe thing to do, is to buy your name. That way nobody else buys it. So I got donlafon.com, and at least twice in the time that I've owned it, I just forgot to pay the bill, and my time ran out, and somebody else could have snatched it up. But fortunately, there's no big demand for donlafon.com. But if one of my if somebody was trying to reach me on donlafon.com and they did a NSLOOKUP and it said that it was offline, it's probably because I haven't paid my bill. Don't buy, if that happens, don't go buy my domain, all right? Anyways, there's a couple additional network troubleshooting you can do. You can use the net command, and there's a number of different net commands here. Net help to get help on all the commands. Net computer used to add or remove a computer from the Microsoft domain. Net config to configure a server or workstation. Used to add or remove shared resources. Start a network service with net start. Stop is the obviously. Net use, used to map a drive letter to a network resource. I mentioned this earlier when I said that I had you can use called you can map addresses like a printer. You can map hard drives as well. We use the net use so that I mentioned, I believe, in one of my videos how the Q drive at my college is the drive for my department, and in that drive we save all the syllabuses, we save all of the mappings for all of the degrees we offer in my department. We keep the student learning outcomes. Every semester we do course learning outcomes, and we save a history of those. Anyways, all on a map drive that all teachers can access from within the college. If you have to be on the college to be able to access those drives. Net user, you can manage user account, allowing access to different users. Net view, to view the network devices that are currently installed. There's also a net DOM, NET-DOM, which stands for domain, and it's used to manage networks workstations from a command prompt. And you can see you can add a workstation, you can join, you can have that workstation, or you can, the one you're currently working to, join a workstation to a domain. You can remove one. You can rename a computer on the domain. You can reset, which will reset the connection between a workstation and a network controller. We can set that domain reset password, and we can also net domain verify, used to verify a connection. Now that reminds me, I jumped ahead to thick client, but I didn't explain thin clients. Let me jump back to thin client just for a moment. Hold on a second. Okay, I just moved back to a previous slide in the presentation that I skipped to talk about thick client. I forgot to go back. So thin client is a way to save your company money. So the reason why let me explain it first. A thin client runs an application from the server. The image management software is used to install an OS and drivers, just the operating system and drivers on the device. And then all of the other information talks about how to connect it to the network. MAC addresses, IP address, monitor settings, domain name, and drivers. Notice you don't load any actual applications because all the applications are run from the server. You can have an application server, for example, that serves Microsoft Office to all of the thin clients. Now, the reason why this saves money is because instead of every 3 years having to update all of the computer hardware, you you don't need that because you will be instead just installing different software on the server and then handing it out to the thin clients. This become the standard in today's networking instead of upgrading computer hardware, which of course means you need every computer in the classroom, for example, has to have incredible RAM and a fast CPU and a hard drive to store all of the files. That's all with a thick client, which we covered, thick client. Thin client, you just have to have a fast connection to the internet. And ultimately, everything is handled by the server. I've been to a couple classes on this. You may focus your career on virtual computers and setting up thin clients and focusing on that type of networking, and you can make a career doing just this. A lot of demand because it ultimately saves the customer money. We haven't gone to it everywhere in the college, but there are a couple labs that are set up as thin clients. I'm going to jump back to my previous place in the presentation. I'll be right back. Okay, here we are back where we were just a moment ago. I'm glad that reminded me to go back and talk about thin clients. Definitely something you need to know about. All right. So when you continue troubleshooting, we can check network interface NIC, uh, your NIC port to make sure that you have lights flashing. That indicates data transfer. If there's no lights um, uh, flashing on your NIC, check your cable. Make sure it isn't broken anywhere. Make sure it's connected completely on both sides. And I say that because especially if you have your network clip, the little clip on your RJ45 connector has broken off. Sometimes that can wiggle its way loose with use, and without a connection, obviously, you're not going to be on the internet. That is definitely something that I look for when I troubleshoot, because when a PC is connected to a switch or a router, it's chattering all the time saying, "Hey, I'm here. What do you get? What's going on? I need an address. Update my address, et cetera, et cetera." Now, look for connectivity indicates for wired or wireless internet connectivities on both sides, and then check the internet router modem lights to see what you have. Is it solid? Is it blinking? Of course, each piece of equipment is going to be different. I highly recommend setting a journal that indicates what the normal operation of equipment is, so that when you have a problem, you can compare the current status of equipment with the previous um, uh, recorded information, so you can see if there's any change. Any change indicates that you have a problem. If you don't have change, well, keep moving. Network servers, authentication, AAA server, verifying credentials. You have a DHCP server that hands out IP addresses from a pool. DNS, translate domain names so that it doesn't have to go all the way to the top level domain or your ISP to get an address, google.com, for example. Endpoint management, discover services, distribute software, update, configure, manage, and re-image. That's where we're talking about thin clients, but even thick clients it's really nice to be a network administrator and not have to get in the car and drive to a remote site to make configuration changes. Instead, you just get on your software and you can manage all sorts of features of end devices without actually going to the device. Mail server obviously manages, controls, and routes mail. Print, it can manage one or more printers. Proxy acts as a go-between between an application and a remote server. We saw that in our video that we played the other day, basically just handing off information onto the net and receiving it from the network. Syslog logs information reported by network devices. That's great. So you don't have to constantly monitor the devices. You have a syslog going to some sort of network management software. That software actually notifies you when there's a problem, so you're not always looking. And it knows that there's a problem because of these syslog messages that your routers and switches will pass along. You can also have a web server providing web-based content for your organization or other organizations. TCP/IP protocol, the AFP, Apple Filing Protocol, obviously filing services for Mac. That AFP, just remember it, Apple Filing Protocol. We don't configure it, you just have to know the term. DHCP, Dynamic Host Configuration Protocol, and you should start building your port information. You should have flashcards for ports because it's something you could be asked. Which of the following ports is DHCP use? You have to know it's 67, 68. DNS, domain name server, translate internet domains and URLs to IP address on port 53. File transfer protocol, you have 20 and 21 and 20. 21, I mentioned already in this class. It is, I think I did. It is for control information, and 20 is for the actual content that's being transferred, the file that's being transferred. Interesting that 21 is the control port. because it's higher, right? You would think it'd be the other way. I always think in my head FTP is weird. And then you have web protocols, port 80 for HTTP, and HTTP over secure layer is 443. Some more IMAP is for mapping address, email received. That does not go away when you download it. I think we already talked about that in this class. If not, it's in my Cisco class. We just covered it. But POP, when you download it, it goes away. That's port 110. IMAP, when you download email, it doesn't go away. It stays on the server. That's 143. LDAP, lightweight directory access protocol. It's dealing with directory services. That's on port 389. And RDP, remote desktop protocol, remote computer connectivity on 3389. Few more. SSH, secure shell, being able to remotely access a switch or a router. It's on port 22. SMB, server message block. Did I cover that in here? I don't remember. But server message block, that's how you can map a hard drive or a printer. It's on port 445. That's on Windows. SLP, server location protocol, announce and discover services on port 427. SMTP, that's on port 25. SMTP is how you send mail. It doesn't stand for send mail, but that's how I read it. Send mail. So send mail is how mail is transmitted, port 25, whereas POP3 and IMAP is how it's received. And IMAP, it maps the address so that it's there, it doesn't go away until you delete it. And then POP3, it goes away as soon as you download it. Those are the three mail protocols. Hopefully that helps you to remember them. Just read send mail and you'll be fine. SNMP, Network Management Protocol, it deals with those syslog errors that you'll get on a network, and it is what allows you to manage network devices remotely. That's 161 and 162. And Telnet is unsecured port 23. So SSH is on 22 and Telnet's on 23. That's another weird one because Telnet definitely came first, so you would think it would be the lower number. But SSH is 22. The way I remember it is I look at this and it's kind of like an S. It's an upside down S, and there's two S's here in SSH and SS, right? And then the next one is Telnet. There's no S's in Telnet. Well, it's not two S's in Telnet, so 23 might help you to remember that. You already got 20 and 21, so the next one is 22 SSH, then 23 Telnet. You've got to get into a habit of trying to memorize in any way you can, these port numbers because they're all testable. Shared folders, Windows, you can share a folder so people can access a folder. Remember, I was talking about the Q drive. Now, the Q drive, when I mentioned it, it's just a drive letter and there are files located in there. Just like Cheryl's PC is shared on the Z drive, or at least she's about to set it when she hits OK. When I say we have a mapped Q drive, it doesn't necessarily mean that the hard drive is labeled Q like your C drive is on your computers for programs. It's just that when you mapped the drive, they mapped it as a Q drive. It could just be a folder, and probably is just a folder on a file server that handles all of the different departments' access to shared content, and we just happen to have the Q drive. It could be, the Z drive for the English department, and the X drive for the science department. It's just how they map it. It doesn't necessarily mean there are that many hard drives that you get all the way up to Q. Ways to connect to the internet. You can connect, and we talked about this earlier when we talked about physical connections. You can connect via coax cable, cellular network. You've done that a zillion times on your smartphones, right? You're oversell when you're surfing the web on your phone, right? Dial-up uses traditional phone network services back in the day. That also is for satellite. So it's satellite download, dial-up upload. That's why upload is slower than download. Your satellite dish is not transmitting to the satellite. It's the other way around. It's just receiving a network, and then you're using your dial-up to access, to send data back. DSL, digital subscriber line. It's an older form, along with IDSL, using traditional phone networks. They were step-ups from dial-up. Today we have broadband, cable, fiber. I have fiber to my house, and of course satellite if you are living out in the boonies and you don't have an ISP that can deliver broadband to your home. You probably have a satellite if you want a connection faster than dial-up. All right, and well, you might use cellular too. If you have cellular towers, you might use a hotspot as well. And today, that's becoming more and more popular. That's it. That is all of the chapters. Plenty. Again, this is the book. We're covering CompTIA A+ certification software. This was our last part of networking. It kind of threw a whole bunch of little things into one presentation, but we got through it. You're prepping for the 221-1001 and 220-1002 A+ certification. Hopefully, you will take that exam as soon as you finish my set of videos and this course, or if you're watching it online. Once you finish this course, I highly recommend that you just start taking some practice exams for those that certification, and then go take the certification. If you've been around computers for a while, my presentations are probably pretty easy for you, and you're probably saying to yourself, "Why am I in this class? This is so easy." But the test actually is challenging. I passed it, but on the first try. But I am a computer teacher. Make sure you take some practice tests so you get an idea what the question types are, and then you will be better ready to go online. Maybe at the end of my last presentation, I'll include some testing software locations where you can get additional resources. Anyways, that is my presentation. Any questions? All right. So if you are here with me live, you can ask a question in just a moment. Hang out. If you're not here with me live, ask your questions in the help discussion forums if you're taking my Canvas class, and ask out on YouTube if you are down below in the comments. I always answer those questions. Maybe it's not the same day you ask them, but I'm pretty quick about it. Ask your questions and I'll do my best to answer them, but feel free to answer each other's questions. That's awesome when you do. You can also just comment down below if you found this video helpful. If you have any recommendations, I'd be happy to take them. And like and subscribe, and hit that notification bell so you're notified when I release additional videos. Here we are in the summer of 2022, and I'm releasing these videos about once a week. And if they're helpful for you, make sure you get notified when the next video is out. If you're taking it after the semester, then you will probably already have all the videos. So enjoy the next video when you get there. Anyways, my name is Don LaFont, Professor Don. It's been my pleasure to teach you today. Hopefully these videos are helpful. If there's anything I can do to help you on your way to A+ certification, please let me know. It'd be my pleasure. Have a great week of learning, and I'll see you again in a week or so.